Alright guys, today we're going over properties of relations between sets, and those properties are reflexivity, irreflexivity, symmetry, antisymmetry, and transitivity. Here are the formal definitions. I'm not going to go over them because I feel like it would just confuse you more than anything else. But basically, whenever we're looking at the set of relations, we want to ask ourselves 5 questions to determine these properties. For reflexivity, we want to ask, for every x, is there an element such that contains x comma x, or an example of that would be 2 comma 2. If we're missing even one of these for any x in the element, then it is not reflexive. Am I missing, and that would be the definition of irreflexivity, am I missing all of these, all of the x comma x pairs? If I am, then it is irreflexive. So if we have even one, it's not irreflexive. For symmetry, if I have an element such that x comma y, do I have a corresponding element y comma x? For antisymmetry, we ask ourselves, do we have no occurrences where we have an element x comma y and y comma x? Are there no occurrences of this excluding when x equals y? And finally, for transitivity, if we have the element x comma y and the element y comma z, do we have a corresponding x comma z element? And to put these, drill these home, we're going to do some examples. So let's define R as a set containing the elements 1 comma 2, 2 comma 3, and 3 comma 1. So we can already see, thanks to my nice marking here, this is not reflexive. And the reason for that is because we can see here our first x is 1. The question we have to ask ourselves for reflexivity is, do we have every element in the set such that x equals itself? So we would need 1 comma 1, we would need 2 comma 2, and we would need 3 comma 3. We don't have any of those, so this is not reflexive. But the question we had to ask ourselves for irreflexivity was, are we missing every element we would need in order where x would equal x? So are we missing 1 comma 1, are we missing 2 comma 2, and are we missing 3 comma 3? Yes, we are, so this is irreflexive. For symmetry, we wanted to ask ourselves, if I have 1 comma 2 and I have 2 comma 1, or excuse me, if I have an element 1 comma 2, do I have the element 2 comma 1? Or more abstractly, if I have the element x comma y, do I have the element y comma x? In this case, I have 1 2, but I don't have 2 1. Here I also have 2 3, but I don't have 3 2. So this is not symmetrical. For antisymmetry, the question I had to ask myself is, excluding when x equals y, so excluding if we have something like 2 comma 2, do we have no occurrences where we have elements x comma y and elements y comma x? So here we have 1 comma 2 but no 2 comma 1. We have 2 comma 3 but no 3 comma 2. And we have 3 comma 1 but no 1 comma 3. So therefore this is in fact anti-symmetrical. And finally, for transitive, we have to ask ourselves, if we have an element x comma y and an element y comma z, do we have an element x comma z? So let's take this for example. Here we have 1 is the x, 2 is the y. 2 is the y, 3 is the z. Do I have an element where 1 is the x and 3 is the z? No, I don't. I have 3, 1, and that does not meet our requirements. Therefore, this is not transitive. And quickly, let's blow through the rest of these. So here we define T as shown. Is this reflexive? Well, yes, we have every x and an element with itself. So that is reflexive. Is this irreflexive? Are we missing every single x such that it equals itself? Well, clearly we're not. So that's not irreflexive. For symmetry, if I have an element x comma y, do I have an element y comma x? So in this case, 1 is the x, 1 is the y. Do I have an element where 1 is the x, 1 is the y? Yes, I do. So anytime you see you're given a set where it's just elements where x and y are equal, it is vacuously true that it is symmetric. So we're going to say that's true. And then finally, anti-symmetric. Do we have no occurrences where we have x comma y, and y comma x. Here's the important part for this. Excluding elements where x equals y. So for all of these elements, x equals y. Therefore, if we exclude them, then we do have no occurrences where we have elements x comma y and y comma x, because there's nothing else left. So we call this vacuously antisymmetric. Finally, transitivity states, if we have x comma y and y comma z, do we have x comma z? So here we have 1 comma y, and then we don't have, because all these are the same, we don't have any instance where we have x comma y, then y comma z. So therefore this is not transitive. Finally, we'll blow through this one. We can see right off the bat that we're missing 1 comma 1, so it's not reflexive. We can also see that we are missing every element where x equals x. So we don't have 1 comma 1, we don't have 2 comma 2, and we don't have 3 comma 3. Therefore, this is irreflexive. For symmetry, we want to ask ourselves again, if we have x, y, do we have y, x? Well, here we have x, y, 1, 2, 2, 1, y, x. Yes, we do. We have 1, 3, x, y, 3, 1, y, x. Yes, we do. We have 2, 3, 3, 2. So this is, in fact, symmetrical. We're clearly not missing all pairs, so this is not anti-symmetrical. If it were anti-symmetrical, we would need to have 1, 2 and no 2, 1, 1, 3 and no 3, 1, and so forth. But because we clearly have all of them, it's not anti-symmetrical. And finally, transitivity. If we have an x and y and a y and z pair, do we have x and z? So here we have 1 and 2, x and y and z. So do we have 1 and 1? No, we don't. Again, here we have 1 and 3, x and y. We have 3 and 1, y and z. Do we have 1 and 1? No, we don't. It's the same thing. So this is not transitive. And that is how we go about applying the properties to sets of relations.